all, what will be given to you is the message D is given to 10100011110, right? And then the pattern P, which is 110101. So this is 6 bits. 6 bits is equivalent to degrees of 5. Degree of 5. So if it's asking you to do CRC circuit and generate the transmission bit, firstly you're going to take the pattern P here. So this will help you make the CRC circuit. So you need the pattern P. So says here that is 6 bits, right? 6 bits, right? So this is degree of 5. So firstly, you take that degree of 5, you come out with C4, C3, C2, and then C1. Lastly, you will have C0. So that is 1, 2, 3, 4, 5, which is degree of 5. Once you have all these boxes here, you'll put the XOR gate in between all these boxes. And then lastly will be, let's say, you can put here or you can put here. Doesn't matter, but I think preferably you put it here, considering that the output of C4 will go back into here. The flow will be from here to here, here to here. Okay, so from, you can see that the arrow here goes into the XOR, so then bits will be flowing into this way from right to left. Okay, let me just do this. Right, so now you have the initial circuit. You take the pattern P here and then you fill up on top of C4 1 1, and then the gate 0 1 0 and 1 1 1 0 1 0 1. So with any of the XOR gate that has 0 bits, you cancel it out and then you generate the next the final circuit, which is C4, C3, C2, C1, and C0. Like I said before, any of the XOR gate that has 0, you just cancel it out to have it look like this. So from C2 you just go straight into C3, and then C0 here just goes straight into C1. So this one's remain, any XOR gate that has 1, leave it be, it will remain. Okay, wait, sorry, you still have to put arrows going into each of the XOR gates, so that will have you the final CRC circuit. So there you have it. This is the circuit that you want. So from the circuit that we have here, you want to generate how it works. You want to know how it works. So from here, start with C4. So how does C4 work? C4 is equal to C4 XORed with C3 and then the initial value. And then C3 is basically the old is C2. You take the value from C2. And then C2 is basically C4 XORed with C1 XORed with the initial value. The initial value will be given to us, which is the data. Okay, and then C1 XORed with initial, and then C1 is equivalent to the old C0, and lastly C0 is C4 XORed with the initial value. So this is how operation of our CRC circuit. Ta-da! Right. Okay, now we need to generate a table. So you'll have a few columns with these values: C4, C3, C2, C1, C0, and the operation. I'll just write it down. C4, C3, C2, C1, C0, and then you just straight in the middle. You put all the operations that I listed down. C4 XORed with C3, XORed with I, and then just do like that. C4 XORed with C1, XORed with initial, straight down. C4 XORed with initial, straight down, and then initial, I equals to initial. So you have all these columns. Sorry, let's do this. Straight down. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. 10 columns, including this one. So how many rows do you want to have? That depends on the data bits that is given to you. So this one is 10 bits. So you will have 11 rows. Why 11 rows? Because why 11 rows if it gave us 10 bits is because you want to include the initial row. The initial row is the values that you put into the circuit, the initial value. So usually we will start with values of zeros. It really depends on the question. If it says that it wants to initialize with this type of bit, then you have to start with that bit. But since this one is not stating any amount of bits, so you'll just assume it starts with zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, you can't see what I'm doing. I'm just creating rows. 10, 11. Right? Okay, so it's 11 rows. So what you want to do is first fill in the, I think you can easily see it right here. What you're going to do is fill in the last column, which is the initial. The initial is the data that was given to us. So this is in the horizontal position. So what you want to do is transpose that value. So it's 1, 0, 1, 0, 0, 0, 1, 1, 1, 0. So like I said before, what you're gonna do is you're gonna start with the initial values of zeros. 9, 10. So here fill out 0, 0, 0, 0, 0, sorry. And then you have to do the operation, XOR operations here. So C4, C3 initial, 0, 0 is 0, 0 with 1 is 1. C4, C1 initial, C4, C1, 0, 0 is equals to 0. And then with initial, 0, with 1 is 1. And then C4 XORed with initial, 0, 1 is 1. So what you're going to do next is, for the next iteration, like I said previously, the operation of C3 and C1 is the old C2 and C0. So you're just going to do this for each row. all rows basically. I recommend you just doing the arrows like this so that it won't be confusing for you later. I understand that there's like a lot of numbers, so it's just easier for us to see. Alright, so basically the old C2 will go into the next iteration of C3. This one, old C0 will go into the next iteration of C1. Okay, I'm gonna continue on. So basically 0 and 0, right? And then the values that we got previously, 1, 1, 1, will go into C4, C2, C0. So this one goes into here, this one goes into here, this one goes into here. And then you just repeat the process. So that's it's a very repetitive process. Okay, so let's just complete this one. Okay, and then I'll just fast forward the rest of it so you can see it and fast forward. Okay, so C4, C3, 1, 1, 1, and 1, 0, 1, 1, 0 is 1. 1, 1, 0, 0, 0 is 0. Sorry, I think I made a mistake. C4, 1, 0 is 1, 1, 0 is 1. Yeah. C4, 1, 1, 0 is 1. And then you just repeat the process. 1, the old C2 goes into the next C3, the old C0 goes into the next C1. And then values of this 1, 1, 1 goes into C4, C2, C0. 1, 1, 1. There you have it. Then you just repeat the process. C4, C4, C3, 1, 1, 0, 0, 1, 1. C4, C1, 1, 1, 0, 0, 1 is 1. 1, 1 is 0. And then just put here, 1, 1, 0, 1, 1, 0. C4, C3, C4, 1, 1, 0, 0, 0 is 0. C4, C2, C4, C1. 1, 1 is 0, 0, 0 is 0. 1, 0 is 1. And then you just put 1, 0, 0, 0, 0, 0, 1, 0, 0, 1. C4, 0, 1, 0, 1, 1, 0, 1, 1, 1, 0, 1. Right. I'm just checking. Right. Yeah. Basically, that's it. C1, 0, 0, 0. And then 1, 0, 0, 1, 0. 1, 0, 1, 0, 0, 1, 0, 1, 1, 0, 1. 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0. And then we have 1, 0, 1 is 0, 0, 1, 0, 1, 1, 0, 1. And then we have 0, 0, 0. I just put 0, 1, 0, 0, 0, 0, 0, 0. And then we have 0, 0. Oh, sorry, I missed it. I forgot to do this one. 0, so 0, 1, 0. Lastly, you'll get 1, 0, 1, 0. So here you go. This is the last operation. So basically, what you're gonna say is that the transmitted bits are from the original data 1, 0, 1, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, and then you can see 1, 0, 1, 0, 0, 0, 1, 1, 1, 0, and then you'll just add the last bits here 1, 2, 3, 4, 5. 0, 0, 1, 0, 0. So these are all the bits that will be transmitted. Why it ends here? Because you don't have anything else to do the operation with. Basically, there's no bits left here, so hope that helps.